Be quiet, you.
You have to treat me very, very carefully. I'm not well.
Yeah, I can tell.
Yeah, this is going to be a good night session. I'm standing by.
Yep, no worries, Steve. Thanks.
I wish you well, Steve. Okay, been there, done that. So I'm on the improve slowly. Roger, Roger. Okay, 1 minute to go. Better stand by.
Oh, pardon me. Good evening. This is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater, VK3 RTV, digital channel 1 in full HD, and also on my YouTube channel, if the stream hangs in there and doesn't fall over. Usually previous broadcast, it hangs in for the whole hour and then decides to fall over during the callback. I can deal with that. Anyway, it's it's hanging in there right now. Anyway, just search for VK3CSJ, VK3CSJ in the search engine, and also on Discord. And as I say every week, if you register on Discord, and that process goes relatively smoothly for you, I provide a link to the chat room, and hence the HD stream on both my QRZ pages, both QRZ pages for this call sign VK3EKH. And also VK3CSJ. Trying to make sure I do keep the audio level down a little bit because YouTube doesn't like me screaming into the microphone. So I'm just making sure that's just occasionally clipping into the red according to vMix, which is working for me tonight. Last week I panicked in the last 5 minutes trying to get vMix up and running, and it kind of stuffed me up. If you wish to send signal reports, VK3EKH@gmail.com, VK3EKH@gmail.com for any signal reports or any potential articles that you might find that might be worthwhile reading over the air as well. We're coming down towards the end of the year, of course, and I'm slating the 20th of December to be the last broadcast for this year, and I shall take a 4-week sabbatical. Normally I take 3, but I just feel like taking 4 weeks this time. So I will be back in the 3rd week of January, I think is how it works out. Let me just quickly skip to next year. And it will be, in fact, Neil Diamond's birthday, the 24th of January. I'm a fan of Neil Diamond's, that's why. Anyway, the 24th of January is when I will be back for the break over Christmas, and I go back to work on the 20th that week too. So I hope to get a few things done over the 4 weeks. Anyway, a pleasant good evening to everybody. I trust that everybody is in good health and is is in good health, and you don't have any colds, except for one person. Anyway, good evening everyone, and thanks for joining in tonight. And I've got a few articles tonight, but last week I should have started off with the Sky Notes, courtesy of the Melbourne Planetarium, and because they were there available to read through, but I will do that tonight. So before we go into Sky Notes, there's no space weather report from Tamitha Scove. She hasn't updated any recent video releases, so we will have just the normal space weather report from spaceweather.com. And there's a bit of a story attached to there that's just some news of recent things that have occurred, which I'll update you all on in about an hour's time. Also, a very pleasant good evening to Sam, if you're listening or watching tonight. Sam from the company where I work, and maybe his son. So if you are watching, Sam, you're more than welcome to send me a text message. I'll open up my phone and I'll just have it sitting there, so you can let us know that you're watching, or you're more than welcome to send an email to vk3ekh@gmail.com. Anyways, let's see. All right. First thing to get off on, the ASV, the Astronomical Society of Victoria, is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. I think it's around 1,800 now. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our 2 metropolitan locations. Yes, Sam is listening. Good evening, Sam. Right, yes. So the ASV has weekly activities at our 2 metropolitan locations, Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our Astro Talks. And for over 50 years, the ASV has played a major role in the care of the buildings and facilities at the Melbourne Observatory. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope. Pleasant good evening to Steve Bentley if you're listening. And are also currently working on the installation of a series of remote telescopes at our dark sky site, which once completed will be accessible to our members for their use. And as far as I know, there are at least 3 astrodomes or scope domes that are now set up and running in this capacity. Thanks to a generous donation from one of its most long-standing and respected members, the Leon Mao Dark Sky site, located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the LMDSS, and makes use of the existing telescopes at the Melbourne Observatory during some of the section meetings and our members' nights held once a month at the observatory. There's also an 8.5 metre, 30-foot telescope, radio telescope, also situated at the dark sky site. and access and involvement with the radio telescope can be done via the radio astronomy section. We have about 20 sections that make up the ASV, and they are, in a nutshell, the astrophotography section, the club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, space exploration, and women in the ASV. All those sections have their individual pages on the website, so if you are interested in any of those sections, visit the ASV website at www.asv.org.au. Look under the sections tab for those sections that I just read out, and like I say, click on each and you'll open up to a separate page describing the details of the section more so, and who to contact if you wish to come along as a visitor to the section, either via Zoom or in person. And the section director will also talk to you about how to join the ASV and whatnot. Right, so the last thing I was about to say in that area was I have to go back finding that section just a sec. Because I get distracted when I talk about radio astronomy, you see. An annual yearbook is supplied to members as well as a bi-monthly newsletter. So this is for those watching the video, this is the yearbook published by the ASV, quite a decent document, and very well put together and edited. It's kind of like an almanac of some sort for astronomers, but it's full of very, very detailed information on astronomy. And this is the bi-monthly newsletter, what this looks like. This is the current one here, very glossy newsletter, or magazine that they call it now, which also is produced by the ASV. And once you become a member of the ASV, there's also an electronic email newsletter that gets organised every week or every so often to keep members abreast of what's coming up, which is a handy thing. Now, next Wednesday, the 11th, is the Society's last monthly meeting for the year. And it's, like I say, it's slated for the 11th, next Wednesday. Usually the monthly meetings always fall on the second week of the month. And there's an Astro Talk happening next Wednesday. It kicks off at 8 o'clock. And fortunately, the ASV broadcast it via their YouTube channel and also on their Facebook page. So the talk will be streamed on video via the YouTube channel, the ASV's YouTube channel, and also on Facebook. And this, I'll be also for those watching RTV, I'll also be running the talk over RTV1 on Wednesday night live. It'll be a live transmission. This week, or next week, this month, the talk is on Colin Stanley Gum, G-U-M, and it is presented by Dr. Kim Thalassides. I think that's how you pronounce his surname. Dr. Kim Thalassides. And yes, he'll be talking about Colin Stanley Gum. And the synopsis I see here is that the largest single object in the night sky and two craters on the moon are named after Colin Stanley Gum, who was born in 1924, died 1960. He was a prominent Australian astronomer, yet few people know the story of the young astronomer who spent his early years in the southern Flinders Ranges before graduating from the University of Adelaide. I've actually got a picture here of him. Let me just bring up the only picture I could find, and I hope that's correct, but I'm pretty certain that's Stanley, Colin Stanley. Someone can tell me if it's not. So yet few people know the story of the young astronomer who spent his early years in the southern Flinders Ranges and later with the first PhD in astronomy from the Australian National University. Despite personal challenges throughout his short life, Gum completed several impressive studies in both optical and radio astronomy, including a photographic survey of hydrogen emission nebula in the southern Milky Way, which revealed the spiral structure of our home galaxy. The presentation will span Gum's formative years in South Australia, and his research and achievements at the University of Adelaide and Mount Stromlo Observatory. Following Dr. Kim's presentation, we will be going across to a presentation by Bill Stent, who's affectionately known as Bill Stent, the telescope gent, and he will be doing a quick rundown of what's in the sky for December. Good on you, Bill. Okay, so the entry there's no fee to roll up to the meeting. The meeting is at the Mulia Hall in Melbourne, the National Herbarium, Mulia Hall. They're suggesting to arrive at 7:45 because the meeting kicks off at 8 o'clock. It's a free entry, and there are tea and coffee, free tea and coffee. As far as I know, it's still free. After the meeting, the aim is to finish by 10 o'clock. But if you can't make it to the meeting in Melbourne, certainly you can view it on YouTube and via the Facebook page, as mentioned before. I might just continue on a little bit longer with Colin Stanley, Gum. Where do we go here? His career, Gum catalogued emission nebula, and in brief, an emission nebula is a nebula formed of ionized gases that emit light of various wavelengths. The most common source of ionization is high-energy ultraviolet protons emitted from nearby hot stars. So he studied the emission nebula in the southern sky and at the Mount Stromlo Observatory using a wide field photography. Gum published his findings in 1955 in a study entitled A Study of Diffuse Southern H-alpha nebulae, or hydrogen alpha nebulae, which presented a catalogue which is now known as the Gum catalogue. And in the Gum catalogue are 85 nebula or nebular complexes. And I've got one image here of this, which I think they referred to as the Gum nebula, in fact. Where it is, there it is. So it's not a very high detailed image, but it gives you an idea of the sort of nebula emissions that he was studying at the time. And so I think I'll put that on the next page here, haven't I? Yeah, so this particular image, which is called the Gum Nebula, or Gum 56, is a vast, almost circular emission nebula that sprawls across nearly 40 degrees of the southern constellations Vela and Papapus. It is so large, yet faint against a bright and complex background, that it is hard to distinguish. Its front edge is as close to us as 450 light years, while its back edge lies at about 1,500 light years away. The Gum Nebula is believed to be the hugely expanded and still expanding at 20 kilometers per second remains of a supernova that took place about 1 million years ago. It contains the Vela OB2 association, the hot stars of which among them just reading ahead of me here. So also embedded in the gum are the Vela supernova remnant and the Vela pulsar, although both these are very much younger. The Vela pulsar being something that's studied daily from the radio telescope in Hobart. It is named after its discoverer, the Australian astronomer Colin Stanley Gum, who published his findings in 1955. So that's just one image. But if you want to see what all the other images that he's photographed, the easiest way to do this is just simply type in Colin Stanley Gum in Wikipedia and go to and look out for the Gum catalogue. And the Gum catalogue has the list of the 85 list of his observations, and pretty amazing what he was studying at the time. So anyway, more information will be on this Wednesday night, this coming Wednesday night, the special presentation at the ASV, and like I said, I'll be broadcasting it on the ATV repeater, and can also be seen on YouTube and Facebook. Right, having said all that, let me just go back to my camera and losing my voice already. This is VK3EKH, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast. Okay, at 20 past the hour, let's now go into the monthly Sky Notes, which is put together by Dr. Tanya Hill, the resident astronomer at the planetarium at Science Works in Melbourne. And this month she talks about the summer solstice. Earth will have its solstice this month on Thursday, the 21st. Summer solstice in the southern hemisphere, winter solstice in the northern hemisphere. Solstice comes from the Latin meaning the standing still of the sun, the standing still of the sun. This is when the path and position of the sun in the sky reaches its furthest extremes and pauses before beginning its 6-month reverse to the next solstice. At the summer solstice, the sun will rise and set at the most southerly points on the horizon. With Earth's axis tilted at 23.5 degrees, the southern hemisphere will be leaning towards the sun. Its rays will be almost perpendicular, giving maximum heat to oceans and land. The sun's path will be the highest and longest of the year, and the daylight hours will therefore be at the greatest. The opposite conditions of winter will apply in the northern hemisphere, where the hemisphere will be leaning away from the sun. Sunlight will be at shallow angle, giving the least warmth. The sun's path will be low and short, and the daylight hours will be the shortest of the year. There's a little diagram here of that too. I should have had up showing on the screen. There's a few links here for you to explore, but that diagram there basically illustrates what I've just been talking about. Melbourne Sun Times. Sunday the 1st of December, which has been and gone of course, the sun rose at 5:51 a.m, setting at 8:26 p.m. By Wednesday the 11th, the sun will be rising. Now I'm not sure if this is a mistake, but I'll go with it anyway. So next Wednesday morning, the sun will rise again at 5:51 a.m., setting at 8:35 p.m. I think the rise time might be not quite right. Saturday the 21st, sun will be rising at 5:54 a.m., setting at 8:41 p.m. And by the end of the month, Tuesday the 31st, the sun will be rising at 6 o'clock a.m. and setting at 8:45 p.m., with the day length being 14 hours and 44 minutes. The moon phases. There's a new moon on Sunday the 1st, been and gone. There's a first quarter on Monday the 9th, a full moon on Sunday the 15th, and a third quarter on the 23rd on Monday. Moon distances. The lunar apogee, where the moon is furthest from the Earth, is on Tuesday the 24th at 404,485 kilometres. Then there will be a lunar perigee, where the moon will be closest to the Earth, on Friday the 13th at 365,361 kilometres. You can almost throw a stone at it. Planets. Mercury, as a daytime object, is too near the Sun to be seen from Melbourne this month. Venus is bright as the evening star, visible from around 9 p.m. in the west before setting by 11:30 p.m. So there you are, Sam. We spoke today about Venus and where it was in the sky. We were exploring the various star tracking programs that were apps that you can use on your mobile phone. I was demonstrating Stellarium, and Sam was displaying another program. But we were trying to find where Venus was in the evening sky. So there it is, Sam. Venus is bright as the evening star, visible from around 9 p.m. in the west before setting by 11:30 p.m. Plenty of time to see it if there's no clouds around. Mars is heading to opposition directly opposite the Sun and will be easily seen in the northeast from 1 a.m. early in the month, from 12:30 a.m. at mid-month, and from 11:30 p.m. late December. It will fade in the early dawn light by 5:30 a.m. Jupiter is visible from 9 p.m. in the northeast and will move across the northern sky before fading in the northwest by 4:30 a.m. Saturn, faint and yellowish, will be seen from 9:20 p.m. in the northwest until it sets at 1 a.m. Meteors. This month, from the 4th to the 17th, and peaking on the night of the 13th, 14th, is the Gemini meteors. They will appear in the northeast. Unlike most meteor showers, which occur as Earth passes through the trail of particles left behind by comets, the Geminids are associated with the asteroid Pantheon, and up to 120 meteors per hour could be seen from a dark sky location. So that's the Geminids, which basically occurring between the 4th and the 17th of December, but the peak will be on the nights of, or the mornings of, the 13th and the 14th of December. So get up early before dawn, and that you might see a few meteors scooting past overhead. Talking about stars and constellations, in the east, if we turn our chairs to the eastern part of the sky, summer offers a rich selection of features to enjoy from the northeast to the southeast. Sirius, which is the principal star in the constellation of Canis Major, the Greater Dog, sits directly east in our evening skies. And to the left is Orion, the constellation of Orion. Very easy to see that constellation, with three bright stars forming a line at his belt. In our southern view, his two shoulders are Bellatrix at lower left and the red giant star Betelgeuse at the lower right. His 2 feet are marked by Regal at the upper left and Sapphire upper right. Well known to many is the local asteroom, which is the saucepan, being right way up. Its base is Orion's belt, and its handle forms the hunter's scabbard or sword. If we turn to the north, Taurus the bull can be seen by finding the red star giant star Aldebaran, which marks its red eye and is one corner of an inverted V. Again, very easy to see that once you've identified this, which forms the bull's head. At 65 light years away, Aldebaran is closer to us than the other stars that are at 150 light years and form an open cluster known as the Hydes. To the left of Aldebaran is a beautiful Pleiades star cluster, or the Seven Sisters. Very, very easy to see Seven Sisters by eye and also through a pair of binoculars. Amazing to view those stars. In many widely separated cultures, this open cluster often represents a group of women, sometimes connected to the figure of a man, as represented by nearby stars of Orion, such as the imagination of our early astronomers. In the west, if we turn to the west, in the southwest sits Sagittarius, the centaur archer. Low in the west is Capricornus, the sea goat, and higher up is the bright Fomalhaut, or Alpha Pisces Austrini. These Latin words get me every time. The principal star is Pisces Austrinus, or the southern fish. If we turn our chairs to the south, low in the south and upside down at this time of the year is the Crux, also known... Oh, hang on a sec. I've just realised I'm not showing the wrong picture here. Let me just go back to my camera here. Sometimes I forget where I leave my my images. Right, I'll just go back to where I was. Okay, there is a picture here actually. So let me just select that. That's probably why I thought of it. Okay. Sorry about that. Okay, so stretching from south. Oh, hang on. Southern Cross and the pointers Alpha and Beta Centauri. In this image that you're seeing on the screen right here, from a 2009 survey of the southern skies, at centre sits the Jewel Box cluster. Part of the dark, dusty Coalsack Nebula lies below, and the bright star at the top is Beta Crux, one of the 4 principal stars of the Southern Cross. Okay, so stretching from south to north is the Milky Way's dense arc of stars, containing large interstellar dust clouds that block our visible light view of more distant stars. Among them are the Coalsack that sits beside the Southern Cross. Very close to Beta Crux, the second brightest star in the Southern Cross, is the famous Jewel Box star cluster NGC 4755, a popular telescope target. From dark locations, it can be seen as a small fuzzy object with the naked eye. And here it is. This is the picture of the Jewel Box. Bringing it up. There we go. Isn't that beautiful? In close-up, the beautiful Jewel Box star cluster NGC 4755 is young, having formed around 10 million years ago. It has 4 prominent blue supergiants and a single red supergiant at its centre, which you can see there. But the cluster has over 100 stars and is 7,000 light years away from Earth. And there's one more image here. associated with these notes. That's the Southern Cross upside down, but what is she referring to here? A mid-December 10 p.m. view looking south with the 2 pointers lower right. Yeah, see, oh yeah, okay. So in this shot, you can make out the Southern Cross, which is upside down, and to the right side of the image are the 2 pointers, Alpha and Beta Centauri. Beta Crux is the part of the jewel box, which is in brackets there. That's what the brackets. You can see the brackets there. So the Southern Cross is upside down, center, and in brackets near Beta Crux is the jewel box, which is that image I showed you just previously. If you can just imagine that little box is in the middle of the screen there, and that's when you focus on that, that's what you would see. Amazing grace, isn't it? All right, now finishing up with these sky notes. Let me just go back to my camera. I've got 2 cameras here. I'll go to this one, I think. All right. The International Space Station. The International Space Station orbits every 90 minutes at an average distance of 400 kilometers, appearing like a bright star moving slowly across the night sky. Here are some of the brightest passes expected this month over Melbourne. On the evening of Saturday the 7th at 10:40 p.m. to 10:47 p.m. coming in from the west-northwest to the southeast, and then Sunday the 8th starting at 9:51 p.m. to 9:57 p.m. coming in from the northwest to the southeast, and then on the morning of Wednesday the 11th at 4:19 a.m. in the morning to 4:26 a.m. southwest to the northeast. So if you want to get up that early, you'll be able to see a morning passing of the International Space Station. But there's a website that will tell you when the International Space Station is approximately going over. It's called Heavens Above, heavensabove.com. It gives you predictions for visible passes of space stations and major satellites, live sky views and 3D visualizations. Make sure that you enter your location in the configuration file for your for exact information that's required when objects are in the sky. But heavensabove.com is a great website for confirming what is overhead and how to see these, or time to see these objects. All right, there's a few dates here for December. I might just go through a handful of these. I won't go through them all. In fact, I'll probably go up to, let's see, next Friday is the 13th. So I'll go up to the 13th and I'll finish off the rest of the dates next Friday. On the 1st of December 1922, solutions to Einstein's equations for space-time and mass energy are developed by Alexander Friedmann. On the 2nd of December 1915, Einstein's general relativity is published on gravity, acceleration, equivalence and space-time curvature. Also on the 2nd of December 1971, Mars 3 by the USSR, first soft landing and return of data from Mars. On the 3rd of December 2014, JAXA, JAXA, Explorer Hayabusa 2, Japan, is launched to asteroid Rogue with a planned sample return to Earth. Also on the 3rd of December 1973, Pioneer 10 makes the first flyby of Jupiter and returns the first close-up images of the planet. On the 7th of December 1676, Danish astronomer Ulrima calculates first accurate speed of light by observing eclipses of the moon Io by Jupiter. And also on the 7th of December, the dates here are the 7th to the 19th. So on December the 17th to the 19th, 1972, Apollo 17, the last moon mission and the longest on the lunar surface at 74 hours, 59 minutes, by astronauts Eugene Cernan and Harrison Schmitt. Also on the 7th of December 1995, Galileo probe USA makes first orbit of Jupiter after 6 years in transit. On the 8th of December 1977, I haven't heard of this one before, HEO-1, H-E-A-O, HEO-1 USA, which is an acronym, of course, for High Energy Astro Observatory. Gee, that's new. I didn't know about that one. HEO-1, High Energy Astro Observatory, is launched into orbit on the 8th of December 1977. I wonder how long that lasted. Also on the 8th of December 2010, SpaceX is first private company to launch, orbit and recover a spacecraft, its SpaceX Dragon. On the 10th of December 1993, the faulty optics of the Hubble Space Telescope are repaired. On the 11th, 1863, birth of astronomer Annie Jump Cannon, compiler of Draper Star Catalogue. On the 12th of December 1970, Explorer 42 satellite is launched to study X-rays. And on the 14th of December 1546, Danish astronomer Tycho Brahe, whose data aided Kepler in his laws of planetary motion, is born. Danish astronomer Tycho Brahe. I think that's how you pronounce it. Okay, I'll finish with that. There's a few other dates there, but I'll finish off those next week. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. Pleasant good evening to all. All right, let me just have a quick look at my email and see if anybody has actually sent me emails. Just acknowledge that for a moment. There's a bit of a break. We've got Andrew, VK3KIS, who's listening on 80 metres with a 509 signal plus. Thank you, Andrew. We've also got Stephen, VK3HK, who's listening. He says, you have been holding up your publications to the wrong camera. Oh, okay. Thank you. That's probably about right too. And then another one, signal report. 509 plus 25. Thanks, Steve. And from Brendan, VK3BKO. Yes, I heard your little announcement before, Brendan. Thank you. he's a real local ham who's listening on the side there. Thanks, guys, for the emails. Like I say, if you want to send us signal reports and anything else, vk3ekh@gmail.com. All right, the image on the screen. You're wondering what this is you're looking at? For those watching the video side of this. This article, published yesterday in astronomy.com, it's titled, Low-Level Clouds Play Surprise Role in Global Warming. A decrease in clouds at low altitudes may help explain 2023's global temperature surge. In a study published today in Science, researchers say that they have solved a climate enigma. The inexplicable surge in global temperature in 2023 rising faster than climate models predicted. By analysing satellite data and weather records, a team of climatologists in Germany have found that the culprit is likely fewer clouds at lower altitudes, lower than about 10,000 feet. Clouds play a crucial role in keeping Earth cool by reflecting sunlight back to space, and clear skies means that more sunlight reaches Earth. The dearth of low-level clouds had gone previously unnoticed because studies that relied on satellite imagery had not been able to distinguish low-level clouds from higher clouds. Worryingly, this trend of clear, low-level skies may be a result of global warming itself, meaning that the Earth may be entering a feedback cycle that could accelerate warming further. The astonishing warming trend in 2023 was first noticed over the North Atlantic, but the warming turned out to be more widespread, says Helge Gosling, lead author of the paper and a climate physicist at the Alfred Wegener Institute of Bremerhaven, Germany. His team also noticed high temperature anomalies in the North Pacific and near the equator. To understand Earth's changing climate, scientists must understand how much energy is absorbed by Earth, how much is trapped in the atmosphere by greenhouse gases, and how much sunlight is reflected back into space before it reaches the ground. Clouds are key, as they reflect roughly 50% of the sunlight that reaches them. By contrast, oceans reflect about 5%. But climatologists couldn't explain all of last year's anomalous temperature rise. To be precise, 0.2 degrees Celsius of warming could not be accounted for even after including factors like the sun's peak in activity, polar ice losses, and decrease in fine particles, aerosols, in the atmosphere. In other words, Earth's overall reflectivity, what scientists call its albedo, had decreased, and scientists didn't know why. What happened could be easily explained by the El Nino or other contributors, says Gosling. That's where these low cloud decreases came into play. Gosling's team began focusing on low-level clouds and how they were affecting the Earth's energy budget. In particular, they used NASA's satellite imagery to track cloud coverage and weather records compiled by the European Centre for Medium-Range Weather Forecasts to track cloud densities at different altitudes. Just hang on a sec. Let me just turn that down. One of the radios in the background there. Where was I? NASA's clouds and the Earth Radiant Energy System (CERS) project compiles satellite data over extended time periods to create a balance sheet of the Earth's radiation budget, tracking how much incoming sunlight our planet absorbs versus how much infrared radiation or energy is emitted back into space. Meanwhile, the ERA5 project at ECMWF compiles and analyzes various data from satellites, weather balloons, and atmospheric instruments on an hourly basis from sea level to an altitude of 50 miles or 80 kilometres, and has done so for a period since 1940. Since CERS only indicates total cloud coverage, the ERA5 was needed to determine cloud densities at different atmospheric levels. Using the ERA5 data, Gosling's team was able to refine their interpretations of satellite imagery, which pointed toward a deficit of low-level clouds, while upper-level clouds held steady. So, what's causing the lack of low-level clouds, you might ask? It may be warming atmosphere itself. If you have greenhouse gases induced warming, many climate models show us that this also has an effect on clouds, particularly on low-level clouds, says Gosling. Gosling says the decrease in low-level clouds could also partly be due to a drop in coal burning and stricter controls on marine shipping exhaust. The fine particles in such pollution act as seeds for forming clouds. The irony is that we clean up the air, we may also unleash more climate change. Fewer clouds reflecting less sunlight means more warming. Another feedback effect, Gosling says, is that as Earth warms, you also tend to see upper clouds moving up into the colder parts of the uppermost troposphere. Colder clouds means they radiate less energy into space, leaving more energy and heat in the atmosphere. It is also possible that ocean feedbacks have led to strong warming of the sea surface, which may decrease low-level cloud cover, adds co-author Thomas Racal. When upper ocean layers become less deep, they warm more easily, he says. Long-term oceanic cycles may also be in play. Atlantic and Pacific oceanic circulations, in particular, are known for varying over decades. These may reduce low-level cloud cover and exacerbate global warming at one time, but produce opposite effects at another. According to Gosling, it is tricky to tell to what extent such ups and downs might confound current trends. Overall, the work shows that the small variations in low-level clouds are more important than most imagined. And Gosling's team reckons that this may mean that the surge in 2023 will not be an isolated event. If a large part of the decline in albedo is indeed due to feedbacks between global warming and low clouds, as some climate models indicate, we should expect rather intense warming in the future, he said in a statement. And that image on the screen that's been circulating there for a little while, fine particles from ship exhausts acts as seeds for clouds, as shown in this satellite image. Tighter regulations on marine pollution means that there are fewer ships' tracks to reflect sunlight back into space. This may be one reason that Earth is warming faster than models predict. Well, there it is. All right, you're tuned to ASV Radio VK3EKH, where the time is 11 minutes to 11:11. Let me see, bring back my camera, make sure I know which camera I am on this time. You're a cheeky lad. Now, next, I'll just briefly touch on to this one. You might wonder what this image is. Bring it up. Close up of my brain cells. No. Courtesy of space.com. Wish the repeater would stop dropping out. Gigantic spider webs on Mars are the next big target for NASA's Curiosity rover agency reveals, published 16 hours ago. Curiosity has just finished the latest leg of its 12-year Mars mission and will now set out to explore miles of web-like surface features left behind by ancient water on the red planet. The zigzagging rocks could also provide clues about whether Mars once harboured extraterrestrial life. So this image on the screen here, NASA's Curiosity rover will soon explore a patch of spiderweb-like boxwork features on Mars. And this photo, it was taken in 2006, shows a similar area to the one that the rover will explore. The ever-reliable Curiosity rover is about to begin a new quest to study giant spider webs on Mars' surface. After successfully concluding its previous mission, NASA has announced the web-like rocks span for miles and may hold secrets about the red planet's watery past. Over the last year, Curiosity has been exploring the Jeddah Valley, a channel carved into the steep slopes of Mount Sharp at the heart of Grail crater on the surface of Mars. During this stage of its 12-year mission on Mars, the rover made some important discoveries, including accidentally unveiling crystals of pure sulfur and finding wavery rocks left behind by ancient lake. Mission scientists also first noticed a large hole in one of the rover's wheels as the wandering robot traversed this region's steep slopes. And there's a self-image here of Curiosity, which I can bring up. There's a self-image, a little selfie taken by the rover itself. Continuing on briefly, boxwork deposits are also found in caves on Earth. They form when salite-rich water fills gaps between rocks and hardens before eventually eroding away. and this is what that looks like. This is what they found on Earth. Oops, wrong thing. vmix. This is what we have on Earth, which is very similar to what we see on Mars. I'll just cut back to Mars. And apparently this is very much the same sort of structures. So that's Mars, and this is what we find on Earth. The article indicates, in the image which you're seeing on the screen now is what they call prominent boxwork deposits can be found in Wind Cave National Park, but are significantly smaller than their Martian counterparts. Researchers hope that Curiosity will learn more about exactly how this happened and what it can tell us about Mars' watery past. Mission scientists are particularly interested in the minerals that make up these web-like structures because they could shed light on whether extraterrestrial life once existed on the red planet. These ridges will include minerals that are crystallized underground, where it would have been warmer with sultry liquid water flowing through. One of the Curiosity mission scientists at the Rice University in Houston, who has been studying the area, said in a statement, "Early Earth microbes could have survived in a similar environment. That makes this an exciting place to explore." Curiosity will arrive at the boxwork at some point in early 2025. So very interesting stuff there to look out for. Excuse me. All right, back to camera one. There we are. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria. Now, let me see. I've got a few more little quick articles here. Have I finished my coffee? That'll take up all of 5 minutes. I'll leave that till next week. I was going to talk about gravity-sized gravitational wave detector reveals hotspot of activity. That's quite an interesting little article, that one. Just to whet your appetite, using the largest gravitational wave detector ever made, we have confirmed earlier reports that the fabric of the universe is constantly vibrating. This background rumble is likely caused by collisions between the enormous black holes that reside in the hearts of galaxies. The results from our detector, an array of rapidly spinning neutron stars spreads across the galaxy, show this gravitational wave background may be louder than previously thought. We have also made the most detailed maps yet of the gravitational waves across the sky and found an intriguing hotspot of activity in the southern hemisphere. So I'll leave that article for next week. This is one I've been holding off for several weeks now. It's just a very quick thing, and I might be able to squeeze it in if I read really quick. Let me see. Where's the picture? There is a little graphic here for this article. All right. Keep clicking the wrong thing. This is called "What is the Universe Expanding Into?" We have heard that the universe is expanding. We've got the evidence of that. We cannot truly say that the universe is expanding into anything else. This is an excellent question and forces us to confront a region beyond the bounds of our intuition. So please bear with me, the author says. When you inflate a balloon, the balloon's membrane moves outward, closer to the boundaries of whatever room encloses it. You can easily visualize this expansion because one object is inflating relative to a fixed enclosure. The notion of the expansion of the universe is more problematic because the universe contains everything. It is a closed space-time system. One could say that the universe is expanding into anything because the question implies that something else outside the universe, which is nonsensical as outside, is a spatially relative term. You have to read that again. However, such an answer is unsatisfactory. Well, there it goes. Let's return to the balloon, and you can see the balloon on the screen. If you can imagine, that's a balloon on the screen. let's return to the balloon. This time, let's draw a series of black dots along the membrane. As the balloon inflates, the dots appear to move away from each other from a perspective of one dot. The more distant dots move away more quickly than those closer to it. As the membrane expands, the dots grow farther apart. In this example, the dots represent the galaxies, while the membrane represents the infinite yet boundless universe. You could travel along the balloon but never come to the end, as it literally is unbounded. And though the balloon's surface might not be infinite in extent, it is not defined by an outer boundary. Note that a shortcoming of this balloon analogy is that it tries to represent three-dimensional reality along a two-dimensional shell. Universal expansion causes galaxies to recede from each other. Galaxies close to us recede at a slower rate than those further away, as demonstrated by the balloon model. The space-time fabric is what is expanding, and the material embedded within it, namely galaxies, moves apart in response to this expansion. We cannot truly say that the universe is expanding into anything else. There is no fixed center, nor is there any rigid outer boundary. It is merely expanding, just as the balloon membrane expands, albeit in three spatial dimensions instead of two. So there it is. If you understood all that, what is the universe expanding into was a question posed by a fellow in Scotland, and that was the answer. You'll find that on astronomy.com. That is under the Ask Astro tab on astronomy.com. What is the universe expanding into? I'm glad I finally got that finished with. That page has been open for yonks. All right, a little bit of a plug for astrophys.com, as I usually do for Brendan. Okay, this is Brendan's latest interview, and Dr. Elena Hyde and colleagues, the York Universe podcast. Regular listeners will remember back in episode 57 of 2018 that we interviewed a wonderful data scientist and astrophysicist, Dr. Elena Hyde. Elena speaks in 4 languages, has 4 undergraduate degrees in astronomy, physics, optical engineering and planetary sciences, 2 masters of degrees in engineering and astronomy and astrophysics, and a PhD in astronomy and physics. She's a smart cookie. Now, back then, Dr. Hyde was an postdoc research fellow in Western Sydney University and a data science consultant. Right now, she is at York University in Toronto, Canada, where she is the director at the Caswell Observatory and is an associate professor who has also developed a wonderful outreach programs. In this episode, we are rebroadcasting They take us on a deep dive into science and science fiction with space launches from the past. We travel through the 70s and a bit of the 50s with space launches from Mariner, Voyage, Pioneer, and to mention just a few. All right, so that's the latest AstroPhys podcast. It's episode 204. And if you just type in astrophys.com, that's astrophys, P-H-I-Z, astrophys.com, you will find Brendan O'Brien's amazing collection of interviews, predominantly with female scientists, and every interview is worth listening to. There is really something of great value in all that. Absolutely fantastic. So, let me see. I keep clicking on the wrong thing here. Back to camera 2. And we now shall go quickly into the spaceweather.com. What's happening with space weather? There's that camera here. So let me just hang on a sec, gentlemen and ladies. Spaceweather.com. There we go. I'm glad to see my internet hasn't fallen over tonight thus far. Now, the first thing I usually kick off with spaceweather.com is talking about the sun. And I'll start off by saying that the solar wind is currently at a speed of 378.2 kilometers a second at a density of 2.7 protons per cubic centimeter is how I usually kick off that. And then I go straight to the image of the sun, which I have here. But the only thing that's changed is that this image is being provided by citizen scientists. Now, this is a note on spaceweather.com. A flood at the Stanford University has damaged a number of important SDO data servers. Repairs may not be completed until 2025. As a result, daily sun images will be coming from readers of spaceweather.com for the foreseeable future. Thank you, citizen scientists. So unfortunately, there's been some flood damage at the Stanford University, which has taken out a lot of their data servers, and which is a bit of a shame to hear. I can just imagine that would be a great loss. So repairs won't be finished until sometime in 2025. So the solar image you're seeing there is being provided by a reader or readers of spaceweather.com who have the facility of being able to take an image of the sun. So, good on them for providing this sort of imagery. It's not the same as what we usually get, because the image that we usually get of the sun is from the SOHO probe, which is in orbit to take detailed images of the sun's surface. So this is what we have to get used to seeing for a little while now. And as you can see, those sunspots that are currently on the sun are numbered. And to continue on, the sunspot number is 101. The radio sun, measured at a wavelength of 10.7 centimeters, is 175 solar flux units. The coronal hole, the sun has got a couple of coronal holes facing our way at the moment. And it says here that the solar wind flowing from these coronal holes could reach Earth on December the 8th through to the 10th. The coronal holes being the dark regions in that image on the screen right now. The aurora over the South Pole is currently looking like this. At least an hour ago it was. So there's not much to write home about. There's not much aurora australis happening at the moment. A very, very faint glow and very, very little activity going on in respect to the aurora. There is something here. Today is Jupiter's closest approach. Today, December the 6th, Jupiter is making its closest approach to Earth for 2024-2025. Extra big and extra bright, the giant planet rises in the east at sunset and soars overhead at midnight, outshining every star in the night sky. Look for it between the horns of Taurus, the bull. So yes, I thought Jupiter looked a little bit brighter than normal. And the other part of this article is Solar Max has arrived. The magnetic froth on the sun. There is an image here. I shall bring up this image also. They're saying that Solar Max has arrived, but only half the sun is fully participating. For the past 6 months, most flares and sunspots have been located below the sun's equator. A new image from Elliot Herman of Tucson, Arizona, adds one more item to the list. Magnetic froth. It is concentrated in a bright turbulent band stretching across the sun's southern hemisphere, and that's what you see in this image here. I wish this repeater would stop going offline like it is. Anyway, I'll move on, and I think that's actually about it really. KP index. I shall mention the KP index. Let me just go to my camera there. Okay, for those interested in the KP index, The planetary K index, at the moment, KP is equal to 1.33, which is considered quiet. The 24-hour max KP index figure is 2.67, which is also considered as quiet. And as of the 6th of December 2024, there were 2,349 potentially hazardous asteroids, but none of those asteroids are on a collision course with Earth, as they always say. So that's about it in a nutshell for space weather. It's pretty quiet for the next few days. Not much solar flare activity is occurring at this present point. So, on that note, we shall conclude tonight's transmission for the 6th of December. And like I say, I have plans to make the last broadcast for the year on the 20th, which is when we finish up at work. And then I'll have 4 weeks off and come back on the 24th of January. But there's still a couple of more weeks to go. Don't forget, next Wednesday is the ASV's Astro Talk presentation, which will be live on ASV's YouTube channel and Facebook page. But I'll also be streaming through the RTV repeater live on Wednesday at 8 o'clock. And talking about Stanley, what was his name? Stanley Gum. What was his first name? Colin, that's it. Colin Stanley Gum. Alrighty then. Now, I shall just have a quick look at messages first. Sam gives the thumbs up. Alright, no worries. And a quick look at email. We have no further emails that have come through. And I should take a quick look at the chat room. And I can see that Dallas is viewing the Discord feed. We also have Steve, VK3SBX. We have Stuart, VK3AUAO, sorry. Brett, g'day Brett, VK2CBD. And Brett, I'm trying to get a hold of the video recording from the NACA presentation. I've been in contact with the person who is trying to get all the videos that was done at the NACA, which was held up at Parkes Radio Telescope earlier this year. And so yes, I'm hoping that he'll organise the video taken of the radio astronomy presentation by Phil Costigan, and also of your presentation. So I'm pretty keen to see that. And of course, our resident astronomer at Mount Burnett, David VK3KDM. It's good to see you guys coming in on the HD stream on the Discord side of things as well. The chat room, a quick look at the chat room. Steve is there, VK3SPX, and David, and Steve, and Stuart, and David. So not a whole lot of chat going on there, guys. It used to be quite busy there in the early days, but it's gone quiet, hasn't it? Doesn't matter. That doesn't matter. All right, let's see if we can dig up any interest on callback. This is VK3EKH listening on 3541 kilohertz for any stations wishing to check in, and I'll just bring up my gain here so people can hear it over the ATV system. This is VK3EKH listening.
VK5 Whiskey Alpha.
VK3 Delta X-ray. VK3SDX.
All right, there were a few stations that doubled there, but I've got VK5 Whiskey Alpha, VK3